System Design Messaging App. Hi guys, my name is Manish Kumar, and in today's session we will work on system design of a messaging app like WhatsApp. So basically what WhatsApp does, WhatsApp allow users to share the text file and media files. It also allow video calls and audio calls, but we will not talk about the video and audio calls. Our major focus will be on the sharing text files and the media files. Along with handling the billion of messages, the interesting part in our today's session will be how servers send the message. So we will talk about protocol like WebSockets. So without any delay, let's start the session and see you in the session. Hi guys, so welcome to my channel, and today we will create a system design of WhatsApp. So WhatsApp basically is a chat application. I mean, it supports the calling also, but as part of this video, we are not covering the video calls and audio calls. Our major focus will be on the chatting side. So the system design, the step one is, as you know, we need to understand the functional requirement. So let's talk about the functional requirement of system. So functional requirement is like it's a chat app, so user should be able to send messages, and messages could be text message up to 200 character long, I guess. And then we have media files like images and clips, video clips, and so this will be send messages. And then user should be able to see the message status. So message delivery status. So message status like is it delivered or like read. Once it shows single tick when the message is sent to the server, and once it's delivered to the end user, it should delivered. When the end user or the recipient read the message, it shows the blue tick, which is like message is read. So yes, then we have what else we can do? The group messages. So user should be able to create group and send messages to the group messages, and just let's call it like maybe up to 100 users. We are not dealing like a huge user base. Up to 100 users, we'll say, will be in the scope. And we how many people will be using the WhatsApp? WhatsApp is very popular application, so I think there may be billion of users out there using WhatsApp. But for the sake of this video, I think we can consider or make some assumptions here, which is like 500 million users base. So 500 million user base, like out of scope thing is like, the interaction with message, and we are not doing any spell checker. Or one more thing is like order of message should retain. Like if someone asking, how are you? Then the answer is I'm fine. They should be in the same order. They should not, like, it should not go backward in that time. Like I'm fine, then how are you? I think that's our functional requirement. So let's go to the step 2. So step 2 is like to understand system better. But let's do the non-functional requirements. So in order to record non-functional requirements, so the system should be highly available for sure, and scalable. We can see we already considering a huge user base, and the media files are also there. And one more functional requirement maybe we want to record here is how long you want to retain these messages. So let's call it like for 10 years maybe. So it should be scalable in terms of database also, because data size gonna grown up a lot, and user base is also huge. So as the load increase, system should be able to handle it, and if it is decreased, then it should go down. So it has to be scalable. And then what else in the NFRs? Yeah, the consistency, because we talked about a little bit in the functional requirement, like order of message should retain. So basically it is good, like if it is, I think it is okay if it takes like 2 to 3 seconds to deliver a message, but once I receive the message as a recipient, it should be there. It should not be like, oh, there was a message, where is it gone? So I'll say it is eventual consistency needed here. And then what else we can think of? As we already talked latency, so maybe like medium or to low latency type, because we are okay for a few seconds if the message takes to get delivered, or if it is like not online or network slow or something, maybe a little more longer to load video files and things. That I think should be fine here. I think that's a good from this video point of view in terms of non-functional requirement. So I would prefer to close our step 2 and jump to step 3 now. Let me save some space here. So the step 3 will be, we want to do little math to understand what database size we are dealing here. So we call it capacity math, or maybe some of us call it back of the envelope estimation too. So that's okay. It's size in terms of like how much data gonna float on the network per second, and at the same time what kind of databases we need, how much big data it gonna be. So those kind of decision we can make based upon this capacity math calculation. So let's see what is the database size gonna be. So if we talk about the media file size here first, because that's the huge one, we can make certain assumptions, which is like, okay, 10 messages. So let's say 100 million daily active user sends 10 messages per day, and out of them, let's say 8 are text messages, because I think majorly like people send messages in the text. So let's say average text message size maybe 200 character. So if depending upon what kind of OS and the machine configuration we are dealing with, but if one character take, let's say generally like 4 bytes, so if it is 4 byte 800 byte, then 64 bit for ID, and the headers and all. So maybe 1 KB seems like to be a reasonable size. So 1 KB text message size, and average media file size, let's say if there are images of 2 to 6 MB, and the text clips maybe go up to 20 MB. So if we say, let's say average is like 10 MB per message, we have 2 media messages and 100 million people. 100 million is 100 into 10 raised to power 6, sending 2 messages per day. Each message size is 10 MB. So here we can see 10 raised to power 3 MB is like 1 GB, 10 raised to power 6 MB is like 1 TB, and this is 9, so PB. So it is 2 petabyte of data per day. So this is definitely going to be a huge database. We need to make sure our DB should be scalable. But the one thing, if you see in these files, these are like just a message, like they just need the storage, because we are not like considering someone editing the videos or like images or something. They send it, they stored on the server, someone want to see them, they can see it in the history. So we simply need a storage for these, and storage is like maybe file system we can use. But file system we need to implement, there is engineering cost involved in it to implement, the scalability and availability to have it replica on different system. One goes down, other can come up. So better option will be, I will say, with S3 blob storage. So in the S3 blob storage, I'm getting like horizontally scalable system storage, and available system replicas, and and even this will be needed in this system, like integration with advanced technology like CDN. So S3, if I use S3, I can easily get all of these things. So I believe or maybe I'll say like this is the recommended way. Simple. Next, we see the data flow per second. So it's like how much data gonna flow per second. So for per second, 2 PB per day, and if I divide by 10 raised to power 5, which is like 100,000. And why I'm saying 100,000? Because 24 into 60 into 60, if you calculate that, this is somewhere around like 80k around it comes out. So I just like to simplify the calculation. I'm calling it 10 raised to power 5 to see how much data gonna flow per second. And so it will be around 20 GB per second. So it's a huge data gonna flow onto the machine. we definitely need some kind of queue or workers to process all the videos and files. To improve performance, I can see we definitely need CDN. Other 100 million users sending 1 KB message each. So this is like 10 raised to power 3 is 1 MB, 6 is 1 GB. So it's 800 GB per day. So because one message is like 1 KB, and definitely this is 800 GB data per day. So this is gonna be huge DB over a period of time. So we definitely need something which is scalable and availability we need to keep in mind. So I will suggest something like the key value storage for this, and that is I'll say DynamoDB, and we can use others also out there, but I'm saying DynamoDB because I have some experience on it, so I'll prefer to use it, and it's like easy to set up. So I'll go or suggest here for DynamoDB. And if you will see the data over network, which is 800 GB divided by 10 raised to power 5, and now you know why I'm saying 10 raised to power 5 here. So this will come out to be 8 MB, 8 MB per second data. There is one more thing which I want to bring here is like metadata. Metadata is like we need to store user information, and we need to store group information. We need to store message information. So I will say a relation database here, maybe SQL I will say. As I already said, I'm like SQL expert, so I always lean towards it. But yeah, you can use others also. So now we talked about the databases, we talked about the functional requirement, we talked about non-functional requirements, we understood how much database size. Now I think this is the right time to talk about the explore different APIs may be needed. And if needed, we can keep adding this API section, but I will say to list out the major things. Definitely a version 1.0 post message, which will have the ID, sender ID, content, and then maybe receiver ID, and timestamp, and the URL, because the video and things URL is like URL for the S3 and the message. So URL, then maybe we will have another for get message. If I come online, I want to get the message, so it will be just my ID. This is my ID. Is there any message for me? Or maybe the last time I received, last timestamp, because I don't want to get the entire list. I just want what is happening from the time I already saw it. So maybe last timestamp. So these looks like for me is the key APIs needed for this application point of view. So I think we can go now into high level design. So this is a sender who is sending the message, and here is the recipient. These are the two portfolio I can think of, user base here, receiver, and here is a chat app service. It store because we want to store message, and then it send a message to recipient, then it will manage groups. So here is the interesting thing. So send message to user. If you see the application, this is the chat app which is sending messages to receiver. So HTTP does not allow server to send message back to the user. User send a request, get a response. That's how it works. So we definitely need the protocol where server can send message to receiver. So we need a live connection established between server and receiver. So a message comes, server knows this is the connection where I need to go to send the message to this user, and then the message received by user. So I will say this is a WebSocket connection, although there are, I think, HTTP2 out there, but I am not so expert about it, so I don't want to talk or go into that. So I will go with the WebSocket. That makes no sense. And then there will be additional responsibility of this service will be notification. And notification I'm saying is like the message status notification. So when the message sender send the message, it is received at server, it send back that I got the message. Then send the message to receiver. Once the receiver get the message, it say like receiver has the message now. And when the receiver will read the message, the client side app will send a notification to server that the receiver has opened the messages now. So then the server will tell back to sender, yes, he read the message. So here, because WebSocket will be costly, so maybe we have to deal with both the things like HTTP connection for especially the services like manage group, create group, yes, group created, notifications. The messaging service especially has to be on the WebSocket. HTTP for group services, group and all these kind of communication, and this is what it will be. And then definitely as we talked, there will be the databases, and the databases will be for images S3, for the text messages Dynamo, and for metadata SQL. This will be like databases here, and that's how it's gonna work. When the sender will send a media image file, it will upload the file to S3. So that's how it will work. Okay, so let's deep dive into that. So we have the user here. He is like a sender. Then we have a service, chat service. And then we have service notification service, because we want to keep the responsibility of sending notification together. Then we have another service which will be, I think, the sending message service. Then we have another service for the group messages, group managing service. So this will be like kind of the key services. So sender and definitely these all are like stateless services because system has to be scalable. So what I will do is like I will say like here are the gateways. Gateway 1, then we have gateway 2, like these are the different gateways here, and gateway up to n, like depending upon how much load are there, so this number will go. So I have a send the message, load balancer here. So when server will be connected, it will be connected and the load will be, and then the request will go to a gateway. Gateway job will be, so what it will have, it will have a, I'm just putting out the session service, and this is the DB, and DB is maintaining a table like something like this, just to give you an idea, like user 1 it's in the gateway 1, then we have user 2 connected to gateway 2, and now gateways are like, know which where this is connected to. And then if I, yep, so now gateway know so now sender send the message to gateway, and now gateway redirect. Gateway responsibility is like definitely auth, like talking to the session service, and then and then redirect messages, and this kind of application definitely need rate limiter also, so we need to put a rate limiter here. So this will send a message to the chat service. Chat service will see, okay, this is the message I have, and it will store the message in the database. Here is the, I'll say the SQL DB. It will store the message here, and if it is image, or something, then it will send back the image, and then the image DB will be going into S3 file. So it will tell the user to use S3. Then user will get a URL and sender will upload the image to S3. Let's run this again. Sender send the message. It goes to the gateway. Gateway redirect the request to the chat messages. Chat message service store the message in the DB that this is the message, this is the recipient, this is the sender and all. App upload the image or media file onto S3 drive. And if it is text message, then this is stored here in the DynamoDB. I'm using the size of database just so we know what is the huge load, where is the huge load and all. So it stored the message into DynamoDB. So rather storing the message into DynamoDB straight, I'll say like here will be a queue. It will send the message into queue, and then there will be the workers who will be like doing this job here to upload that into the DynamoDB. And then chat message service will inform the sender that there is a message, or maybe I'll say like sender will like keep looking into the queue and see like what are the different messages there, and it will take the message from queue and see where the message where the user is like connected to which gateway, which is through the session service. It will check it here and then send the message to gateway 2, and gateway 2 further send this message to recipient. Once the message is received over there, chat message service tell the notification service that I have forwarded this message, so you can just inform. And then sender message will also notify the user, and then notification service is also sending messages to the right gateway. So to know the gateway, everyone is like reaching out to the session service, and session service will definitely be having some kind of Redis cache to store this information. I'll say this is a Redis because this need to be super fast and scalable and available. So if we see the functional requirement, sending message, so user is able to send message. Text message is going to the DynamoDB, we talked about that. Media file the user is uploading into S3 drive, and the data is saved in the SQL DB. And message status, we have a notification service, and then we have the group service, which is another responsibility. So let's say the user create a group. The user can talk straight only to the gateway. Gateway will see this, redirect this service to group service, and now group service responsibility will be to create the group in the DB and tell back the user that yes, the group is created, and send notification of the new group created to all the users. So it will tell all the users that yes, this is created. Now one API we missed is like create group here, which I just want to add here, which is like, you know, group service where like the messages will be something like ID, group name, and the recipient or the members list, and icon and all also there, but I'm not going to deep down, but yes, you know that. So this API will help gateway where to redirect. It will redirect it to the group messaging service, and the group managing service will create the SQL DB, not messaging, it's managing. So SQL DB, and once the group is created, it's notified to everyone, group is in place. Now when the sender will send a message to chat message, it will see that this is for a group. It will put the message in the queue. Now sender will go into this DB and get the group IDs. Once it will get the group IDs, listed group IDs corresponding to the message in the queue, it will put the message into each user queue here. So it's not sender, I think I'll say there will be a worker job here. I'll say the worker's job is here, whose job is, if it is a message for the group, it will go into this DB, get the group ID. It it will get the group ID and create the queues for each user, and then sender will still take on the queue and keep sending the message and notify everyone that this message is delivered to this group. So I want to little bit talk about the DB design here, this because we use the relational DB. So we will have what all things we will have here, the metadata especially, because that has to be, it will be user ID. It's a user table. Let me call it, by which it will be clear this is user table, user ID. It will have the name, contact details like phone number, email, etc., and image or like profile details, profile ID. Then there will another table which will be majorly the profile ID, and this will be foreign connection here, and the icon and the title, like on the headers you want to write on the profile. Then there will be another table which will be the message table, message ID, and the sender ID, receiver ID, content, receiver ID, the timestamp, because we want to show the message in the right order, and the URL. So this will be our message, and definitely sender ID, receiver ID are the foreign keys for with the user table, this one, and the profile ID is also a foreign key with this table, and receiver ID is also user, but receiver ID could be the group also. So this will be a group table, which is group ID and group name, members list. What else? The icon or image for that to to show some kind of identification for the group or the special day for the group. And here the member list will be like a foreign key for a list table, like list ID and the user ID. So this member list is gonna be foreign key for this, and then group ID will be a foreign key in the receiver ID also, and the user ID will also be a receiver ID, and I think the URL will be having the URL for different, like the S3 image and all these URLs will be pointing to them. So this will be the SQL DB. Recipient has to download the image from S3. So I'll prefer to introduce, as we talked initially when we were working to collect the requirements, that it will be through CDN, so that it will be high performing system. So now we can see that we have the CDN in place. So let's run through quickly before we close the session our functional requirement and non-functional requirement. So functional requirement, the first requirement was user which should be able to send messages, text messages, media files. So we can see the text message and media file, we covered about that, we talked about that, and those are handled in the design. Message status, second requirement, we have the notification service, and all the message movement are going through or informed to the right set of users through notification service, that covered. Third is like the group responsibility, creating group, adding member, and all those. We have not talked too much about adding member, deleting group and all. We just took a single use case as part of this design, creating group, but we can extend our design. It's happily expandable for considering all those CRUD operations on the group. So we talked about that. Our group managing service taking care of it. Order of message should retain. So our message has a timestamp. So based on the timestamp, the end user application gonna render the messages. Yeah, that was about the function. Non-functional requirement, if you see, highly available. So we have stateless services. All the services are like, horizontally scalable. The session service will be having Redis cache to store all the data, by which there will be no delay. We talked about different connections, WebSocket, HTTP. So then consistency. Yes, these are the mutual consistent. So once the message is in the queue, stored in the DB, And when the application will get it, it will be with the timestamp for that. Every time application is getting new messages from the time they already see, so the message is there. Are we gonna store entire data onto the end user phone? We may not. Maybe a certain limit will be there. Once they scroll it up and want to see more into history, then it will start loading, getting messages more by sending ID and the duration, and then that will come with the timestamp from the database. And that maybe we can handle as part of separate service. That can be its own service, historical messages serving service kind of thing. So application will say like, give me more for last 10 days, or maybe the number of messages, give me last 100 more messages, give me last more 100 messages for this particular group ID or for particular recipient. And then we have the latency, as we know, like couple of messages, couple of seconds delay is fine here. So but our system, we have like horizontally scalable system, we have load balancer, so the service or the load will be equally distributed across the services. And we can wrap it up, guys, here. So thank you so much. Thank you so much, guys, for joining me in the session. If you found this session helpful, please subscribe to the channel and press the bell icon for updates on future videos. Thank you so much.